SimpliFIED, all the other guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Great. I just wanted to formalize the lesson. Now we are on a formal lesson, the right way. Okay. So with analytical geometry, like I say, a lot of you don't have a problem with this one. For question 1, we're just going to go through it together. When you are given points like that, I always advise you visualize your work. By visualizing your work is those points that are given. Before you even approach any question, we understand it's analytical geometry. We understand if you were to calculate the gradient, you would know that it's y2 minus y1 over x2 minus x1. But analytical geometry always works in terms of structure. So you have to make sure you are able to show the structure that formed from those points. So when you are given coordinates or points like that, you must first draft them down, ideally on a Cartesian plane, as if they were given in the form of a diagram. And after doing that, whatever question you'll be doing after will be as easy as ABC or as easy as DEF. You're just gonna flow like that. But anyway, if we are to construct those points in a Cartesian plane, we would have our x-axis there and our y-axis there. So it's not going to be accurate, just the symbolization of what the points shaped, what type of a triangle that is, because it's 3 points. Whether it's a triangle, we're not even sure. I'm just guessing myself. But then this is the y-axis, and then there's going to be an x-axis. Please hold that thought. Let me answer this text quickly. Okay. Um, right. Like I say, I wish I could multitask. Okay. So now back to what I was saying. We have our Cartesian plane. We are trying to put those points here. Ideally, everything starts from 0, 1, 2, 3, 4, 5. Da, 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 da. I don't necessarily have to number that as such. However, let's start with D. D is -1. So we know that a point is xy, right? And then D is -1 and 2. -1 could be roughly somewhere here, and then +2, we can put it somewhere roughly there, and then the 2 points intersect somewhere there. So that would be our D, which is -1 and 2. I hope I'll have space for the other points. The other points, the next one, E, is +4, +4x and -2y. So suppose we have +1, +2, +3, +4 somewhere here, -1, -2y maybe somewhere here, and then +4 and -2y, they interact somewhere here, which would be E. That would be 4, and minus 2. Let me just move that x of intercepts of mine so it doesn't distract the whole thing. Lastly, f is minus 5x and minus 3y. So f will be minus 5, and then that would go like 0, minus 1, minus 2, minus 3, minus 4, minus 5x, and minus 3y can be somewhere there. So this is minus 3y, and then this is minus 5x. So that would be our point there, which is f, and f is minus 5 minus 3. So according to the structure that we have based on the points, it means the structure would form that type of a triangle. Do you agree now? It does. So now it looks like analytical geometry that we normally see in other question papers, because so they would give the structure in this form. So now this one, we had to construct the structure ourselves. It's not a must to construct the structure, but without the structure, you won't be able to interpret other questions. Do we agree, or we'll remember the part where we have to draw the structure ourselves? Hopefully, né?
Yes.
Now, sure. Now, whatever comes after, the confidence is there. You guys, this part, I know you always kill it. If we had to calculate the gradient of df, it's easy now because you see everything displayed for you. So the gradient of df will say gradient m is equals to y2 minus y1 over x2 minus x1. That's how I would calculate the gradient of for f for 1.1.1. And then for your gradient, you will know how to do your thing. You can choose this as your x1, y1, and then you can choose this as your x2, y2. It doesn't really matter which one you go with, but it has to come out from one point to another. So in this one, would have, if y2 is 3, it's going to be 3 minus y1 is minus 3. So it'll be 3 minus minus 3 all over x2 is minus 1 minus minus 5. There's a lot of negatives going on there, but otherwise for the top one, we have 3 minus minus 3, which is going to change the 3 to be positive, and then 3 plus 3 will give us 6. All over minus minus 5, or multiplied, it will be positive, and then negative 1 will be 5 minus 1, which will be 4. And then 6 over 4, it is divisible by 2 both sides. 2 goes 3 times here, 2 goes 2 times here, so it would be 3 over 2. That is our gradient. 2 marks, gone, you're done. Now, if line DE is perpendicular to DF, which makes perfect sense from the diagram that we draw there. So line DE is perpendicular to line DF, which means we're going to have some perpendicular going on here. And doesn't it make sense based on our diagram? And without the diagram, we wouldn't know how, like, without putting a diagram to answer that question, all of it is going to be a hectic experience. So you would always have to come up with a diagram. Now, if DE is perpendicular to DF, write down the gradient of DE. Who wants to take this one? So now we have the gradient of DF. We just calculated it. This is the gradient of DF. 3 over 2. If the gradient of DF is 3 over 2, and then we are given that DE is perpendicular to DF, what would be the gradient of DF? You can just say the value. Anyone? I just want to make sure you're not sleeping.
We do not have the same value.
They will have
The same gradient.
Only when they are parallel will they have the same gradient. So parallel lines have gradients. Yes?
Will it be y 5/2?
Yes. If when you have two lines that are perpendicular, it's a case where when you multiply both their gradients, they must give you -1. Do you remember that part? Do you remember something like that? So we say
God,
when you
y,
multiply,
yeah.
so that's the case. When like the reason why we have to know if gradients are perpendicular to each other is because we are looking for this punchline about their gradients. So from now onwards, always remember when two lines are perpendicular to each other, when you multiply their gradients together, you must get -1. The only time two gradients will be equal, the only time two gradients will exactly be equal is when you have two lines that are parallel to each other. So for parallel lines, gradients are exactly equal. For perpendicular lines, when you multiply the gradients, you get -1. You will remember, ne? Hopefully. Now, for this one, the reason why they wanted you to get the gradient of DE is because since you already calculated the gradient of DF and you found it to be 3 minus 2, you just go there and then you substitute 3/2 for the gradient of DF, and then we know it's multiplied by the gradient of DE, and then it's equals to -1, and then you solve that thing. And then if you solve that, you'll find that the gradient of DE is equals to -2/3. You can confirm that in your calculations. You just divide 3/2 to the other side, or you just multiply by 2/3 both sides to remove the coefficient of gradient of MD. It's just 1 mark. Let's not waste time on that. We are good, ne? If you don't understand, I can repeat what I said. We're good? Can I proceed?
Yes.
Yeah.
I hope I may. Silence. I hope I may. Okay, so for the next one, we have, so now let me put the information that we have up there. So far, we have the gradient of DF, which is 3/2. And we have the gradient of DE, which is -2/3. These are the two things we have. Now, we are required to calculate the equation of line DE for 3 marks. I don't even know why they make it 3 marks. Y is equals to mx plus c for DE. What is our gradient, Kana, for DE? -2/3x plus c. And then the next thing that is remaining is just to find the value of this c in order to find the equation in the form of y is equals to mx plus c. And to find that c, you either use point D or point E to substitute and get c. Whichever one you choose, it would work. I think the simplest one would be, okay, it doesn't matter. We don't care about the simplest one. We just want to solve that thing. So I'm going to go with the first point. So for y, I will put 2 is equals to -2/x, and then where, y -2/3, and then where there's x, I'll put -1. So I used point D to get c. When we simplify that, we'll get that c is equals to 2 minus 2/3. I'm just simplifying it faster there because I feel like you guys, you already know that for the other side, you would get the negative will multiply with the 2, so you get +2/3. But when you take it to the other side, it will be negative, and it will be -2/3. I don't know how confident are you with solving fractions, but 2 minus 2/3 will give you that C is equals to, let me see. 6 minus 2, it would be 4/3. That's what I saw. C is gonna be. So now, after getting the value of C, and then you just go there and then say your formula for that, this equation will be y is equals to okay, let me not use green. Let me use a color that's gonna complement the scenario. So this is gonna be y is equals to minus 2/3 x plus 4/3. Happy. Everyone would get that, right?
Yes.
Given that,
Yes.
given that you understood the perpendicular part to get your gradient, because otherwise, even if you never did the perpendicular thing, let me show you. Remember, after the gradient thing, we got that the gradient of dE is minus 2/3. We could have calculated the gradient of dE ourselves and say dE y2 is going to be minus 2, y1 is going to be minus 3, all over. Oh, no. Y minus 2 on top. Because the minus 2. And then all over x would be 4 minus minus 1. Wait. dE is 1 and 2. FE is minus 3. And then E is minus 2 and 5. What am I getting wrong here? Wait. So if it's not the same and then something is cooking, it has to be the same. So we have minus 2 unless I did something wrong with the first gradient. The gradient, let me confirm the gradient of df. The gradient of df, I think when I wrote the points here, I might have made a mistake. This is minus 3 according to this. I'm not sure, but I'll confirm now. So we'll have minus 3 minus 2 all over minus 5 plus 1. This is going to be minus 5 over minus 4. So therefore, this is going to be 5/4. Yes. So I made a mistake. The gradient of df was supposed to be 5/4. I think I used the 3 as a 1 previously. I took it from my own handwriting. My bad. So the gradient of df should be 5/4, which means the gradient of dE should be 4/5. Hey, bruh, hadn't I confirmed this gradient, we were gonna just flow thinking, but I'm glad we did. So now it's gonna be that, but then negative. So meaning we got this by doing the perpendicular thing, by saying gradient of df multiplied by gradient of dE, they must give us minus 1. But in terms of the gradient, you could have calculated it exactly and say the top part is minus, okay, so x2 would be minus 2, the blue one, minus 2, the red one from D, all over 4 minus 1. Therefore, that would be minus 4 over positive 5. So that would be if I was calculating the gradient of dE directly without using the perpendicular. So anyway, even if you could have gotten 1.1.2 incorrect, you still had a chance to get 1.1.3 correct just by knowing that to get the equation, I must find the gradient first and then choose one point and then substitute whichever side I want. Still together. Don't trust me too much, guys. Sometimes when I make a mistake, you must say, hey. Because sometimes if I just flow, I just flow. So like sometimes just say, hey dog, I know for some students they believe for people who are like the ones responsible, they don't make mistakes. We need those students who correct teachers in class and say, I challenge you. That is not how this thing is. So I hope we're gonna be able to do something like that. So if G is 6 and Y, now we don't have point G there. G is 6 and Y, meaning X is positive 6, and then we don't know what is Y. And this G is a point on DE. It is a point on DE. Determine the value of Y. So if that is a point on DE, we know that if already D is 6 here, if it's E, it would be like a stretch to somewhere there. So that would be our point D. I mean G, which would be 6 would be somewhere there because it's 4 here, 4, 5, 6. It's going to be 6 and Y. Whatever happens, we already know that we're going to expect the Y value to be a negative because we are on the fourth quadrant of a Cartesian plane. Therefore, to get that, is there anyone who has a suggestion how we get to the value of Y? I think after changing our gradient, that changes our entire value of C as well. Let me get the value of C as quickly as I can. So Y is equals to 5 minus 4 over 5 X plus C. Therefore, C would be, I'll take 2 minus 4 over 5 minus 1 plus C. Therefore, C is going to be 2 minus 4 over 5. And when we simplify 2 minus 4 over 5, it would be 10 minus 4, it would be 6 over 4. Therefore, our equation is Y is equals to minus 4 over 5X plus 6 over 5. So in order to get the point Y, again, it's easy. You just substitute 6. When substitute 6 and Y in that equation, because it's on the same equation. So to get Y, you'd say Y is equals to minus 4 over 5, X is 6 plus 6 over 5. Let's quickly simplify that and confirm our answer together. You just substitute 6 on the equation, you substitute 6, and then we solve for Y. I just want us to substitute together and confirm our answers separately. Let's just do it on our side. I get negative 18 over 5. Is that
I'm
what
also
you guys
getting
got?
that.
You're getting the same, ne?
Yes.
All right. So the length of DE, the length of DF is equals to the length of DE. What type of triangle is DEF? Why would this be 5 marks though? Does it deserve 5 marks?
No.
Is there a mistake that we are not seeing? Because if DF is equals to DE, what type of triangle is that?
Isosceles.
Isosceles triangle. And would we really get 5 marks for just saying that? I think there's more to it. Do we have to prove it? I think we have to determine it. We have to prove it. Let me just quickly confirm something on my side. I will. Dun, 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 dun. Yeah, you don't just say they are isosceles triangle. You have to get the distance each. So you must find the distance of DE as well as the distance of EF. And you remember the distance formula, right? With the distance formula, it's just that part of u square root of x2 minus x1 squared plus y2 minus y1 squared. And then for this one, same thing, x2 minus x1 squared plus y2 minus y1 squared. Because of time, we don't necessarily have to do that. But when you calculate the distances, they're going to be the same. And then after, you will say, therefore, it is an isosceles triangle. Perfect, ne? And then the area of triangle DEF, the reason why it's 2 marks is because triangle DEF is a right angle triangle because DE is perpendicular to DF. So since it is a right angle triangle, already we don't necessarily have to find the height. DF can be our height, and then DE will be our base since it is a right angle triangle. And then we do that, and then we do our thing. I'm gonna leave 1.2 for you guys. You will do 1.2 in your own time, just for, we're gonna come back to it though. You will do it in your own time, but we're gonna do it again. Like I wanna be all over with this paper. I want us to move to maybe circle geometry. Or something else. For question 2, let me ask, questions like this, are they still a problem to you guys?
No.
Not that much, ne? Musidi, are you confident with question 2? Just by looking at it.
Kind of, I suppose. I'm not really.
Okay, let's do this there. You're gonna try it on the side, and then if you try it on the side and then you do this one, it was not that long. If I see it just needed you, yeah. Maybe also finding the general solution, like, but this type of general solution is a bit interesting. Let me stop a bit there. Now, when you try this one, you're gonna try maybe up until 2.2.2.2.2. For you, Kumu, since you are writing tomorrow, when you look at these two, how do you feel in terms of readiness?
Okay.
We are okay, ne?
Mm.
Oh, can I yesterday we did this together, ne?
Yes.
Part. Oh yeah. Sharp. All right, Musidi, you can try question 2, all of it, and then when you're done, maybe we can do it before. All right, just I don't wanna make you feel like you're gonna have a long day like that. So look, whenever you are previously, you were supposed to do it anyway. I'm not sure if you did or you didn't. Probably you might have skipped it because you didn't understand. But then I would like if you could attempt, given that you are allowed to be wrong, you can just attempt, be as wrong as you can, and then send me your ideal solutions. And then we're gonna discuss it together for solutions, for corrections. Ne?
Okay. Also, I wanted to say, I don't think I have the paper. I looked at the
You
last
don't-
question that you sent me, and the questions are different.
And you do. Let me highlight the paper for you so you can see which one we're talking about. Just give me a moment. Oh, yeah. I think I didn't send you this one. You're right. The one that I thought I sent is not. No, matter it is. Here it is. Here it is. Here. I've sent it in the past, not not the recent previous paper I sent. Like it's up above. That's it. That I remember it was during the week we were supposed to have this lesson around 8 o'clock, 9 o'clock, and then I got carried away with some university lessons, and then we ended up not doing it at all. But anyway, we are here now. Okay. Back to it. Yeah, question 2 is a bit long. We then have questions like this. You just need to remember what's happening with quadrilaterals. You just need to remember the parallel, like that's when quadrilaterals could be having two lines that are parallel. When two lines are parallel, there are those things that you need to remember. That's when you're gonna have your alternating angles, corresponding angles, co-interior angles, wara, 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 wara. But we can also explain it in terms of sides. Now, for 2.4, I don't know if I should leave it or should we do it together. What do you think, Kumo, since you're writing tomorrow?
Can we do 2.4.3 and 2.4.4?
We might as well just do we might as well just do all of them because that's that's just the heart of it. And I think we might need information from 2.2.4, I mean from 2.4.1 and 2.4.2 in order to proceed with the other ones. Now, just for the sake of the vibe, here we have in the triangle, in the quadrilateral below, ABC, angle ABC is 36 degrees. Angle CBD is 80 degrees. Angle BDC is 60 degrees. And line AB is 74 meters. And line BC is 52 meters. Calculate the value of angle BCD. Okay. That one is not a problem, ne? Okay, I understand now. So angle BCD, it's gonna be this one. Angles in a triangle, we know there are 370, right?
180.
Okay. Okay, I'm just joking. Like I say, I keep on wanna check if you're not sleeping. So because normally if we were on one, if we're having a one-on-one lesson, we'll talk properly. But I know if there's Tunyana people don't want to talk to a point where some they just feel like. So since they are 180, if you add 80 plus 60, you get 140. What is missing for you to get 180? It would be a 40 there. So that would be 40 degrees. And then the length of line CD, the length of line CD for 2 marks. What is the length of line CD? Isn't it tempting to say line CD is 74 meters?
It is. But
But
So
don't
the
be
other,
tempted.
they didn't. Are the lines parallel?
They
yeah.
didn't specify anything. They just told us about the size of the angles and the size of the other lines. So we do not know anything. But you should be happy because you know the sign rule. Right? Okay, please pause a bit. I'll be with you now, ne? We'll come back, ne? I have to end this lesson for now. We'll come back, ne?
Okay.
Yeah, I'll send another link. I just have to attend to something. Ish. If I can proceed, let's pause from there, but try it. Try 2.4.1 to 2.4.2. We'll come back now. To find CD, you can use the sign rule. We'll take it back from there. Remember the sign rule, ne?
Yes.
Sure. I'll be with you.